We all like playing Minecraft, but we all know that Minecraft is missing one small detail: guns. Guns were invented in the 10th century, but only added to Minecraft in 2026. That's what I would have said if guns were actually added to Minecraft in 2026. But instead, we got the amazing game Ace of Spades, released in 2012. Unfortunately for the gamers, the game was abandoned and all of the servers closed due to very low player activity. And only hope is what remains. Hello gamers, hackers, and ladies. This is your favorite maniac. In today's video, we will explore what exactly open source games are. We will dive deep inside game developing techniques, talk about client-server relationships, and obviously, hack the game and find a vulnerability that will let us fire like maniacs.
This video is for educational purposes only. It is intended to explain game hacking concepts for learning, research, and cybersecurity awareness. Do not use the techniques demonstrated in this video to cheat.
Yo, shut your bitchy ass up. In this video, we're going to take a look at an open source clone of one of my favorite childhood games, OpenSpades. OpenSpades is a clone of the OG game Ace of Spades. I used to play this game with my friends for days. Luckily, a group of amazing people decided to recreate the game, make it fully open source, and continue maintaining it. And to this day, there's still a small community keeping OpenSpades alive. While making this video, I noticed that there are usually around 10 players online at night and around 20 players during the day. Most of the community is made up of super nice people who are still playing the game for the nostalgia. Okay, enough yapping. Let's start gaming. For starters, let's understand what the fuck open source is and why it's much easier to work with open source projects. Imagine you're writing code for your secret program. Your program calculates keys using a super secret method, and those keys are then sold. When publishing your program, you don't want people to know how those keys are calculated because that would be like a restaurant revealing its secret recipe. So instead, after you finish writing the code, you compile it for different architectures and operating systems, and you only publish the finished program without ever showing the source code. This is called closed source. Most of the programs we use today are closed source, such as Windows, Steam, and many others. Open source is basically the opposite. Instead of publishing only the finished program, you publish the source code as well. This allows anyone to look through the code, modify things, suggest changes, and, depending on the project's license, use the code for their own purposes. Now that we understand what we are facing with, we can actually start gaming. First thing to do is pray. Say thank you to God for another great day outside. And right as we finish, we open up OpenSpades repository on GitHub, and we try to compile it. We start by cloning the repo locally, then follow the build instructions for hours, trying to compile it, and failing. Then, after a few hours of debugging and talking to my son, ChatGPT, it still fails. But after even more hours, we finally manage to get it working. Right, so now that we can compile the game and play it normally, let's hop into a random server and see what we can do to understand the game a little better. In my case, I tried to place a block on the spot where I was standing. Obviously, the game doesn't allow that, and as we can see, a pop-up message is shown on the screen. This is a great starting point for researching the game. We open the code and search for the exact string that is shown on the screen. In this case, most of the strings are inside random files that represent different languages, but those files still contain references to where the actual strings are used in the code. In our case, we can see that the string from the pop-up message is used inside clientupdate.cpp. Using that, we managed to find the code responsible for sending block actions to the server. For example, placing a block. Just for some testing, I decided to change the code a little so that it sends the x-axis position of the block shifted by 5 units. Now, when playing, we can see that the blocks are placed not exactly where I pointed, but rather 5 blocks away. We can also notice that some blocks are not placed at all, and a pop-up message is shown. I played around with it a bit, and I came to the conclusion that the server most likely performs sanity checks on block actions. We'll see the actual server later in the video, but what I think is happening is that if the player is too far away from the block, or if the block is being placed in the air, the server simply denies the request and sends us the pop-up message. This is an excellent moment to talk about client-server relationships. I'll start by saying that every game implements things differently, so what happens in Game A might not happen in Game B. In OpenSpades, there are a few open-source server implementations. Most of them look pretty similar, and that's because they're basically forks of the main server repository, which is called PySpades. So, what is the responsibility of the client, and what is the responsibility of the server? The most basic and obvious responsibility of the server is to connect the players and relay actions between them. For example, if player A places a block at coordinates 10, 20, all of the other players need to know about it so their games can render that block. So the server receives the request to place a block at 10, 20, and then sends that information to all of the other players. But because the server is such a central part of the game and basically manages everything that happens between players, it's also a great place to perform sanity checks. For example, every time the server receives a request to place a block, it can check whether that block is being placed in a valid position. If the position is legal, the server accepts the action and tells the other clients that the block was placed. If the position is illegal, for example, if the block is floating in the air, the server denies the request, and none of the players will see the block. An important thing to understand is that the client can technically do whatever it wants locally. I could completely change the client code to make the game look like Minecraft, or I could add a minigun weapon to my version of the game. But none of the other players would see those changes unless the server recognizes and supports them. That's the key idea. The client controls what happens locally on your machine, but the server decides which actions are actually accepted and shared with everyone else.
Back to the video. There are a million ways to hack a multiplayer game. We could take advantage of data that is sent from the server, for example, to create wall hacks. It's basically just rendering the other players because their positions are already being sent by the server. Or we could find some kind of game logic that isn't enforced by the server, or at least isn't enforced well, and exploit it. I tried making a fly hack. The most naive way to do it is to make the function that checks whether we are on the ground always return true. This allows us to jump in the air repeatedly, which is basically flying. But as we can see, the server fights against us and tries to correct our position. I tried avoiding the server's correction packets, which resulted in my player actually flying on my screen, but other players saw me stuck at spawn. This is because they aren't ignoring the packets that correct my position like I am. Doing this led me to discover another bug in the server. When I flew to the top and started shooting at players, sometimes I killed them and sometimes I didn't. This is probably based on my position and my enemy's positions. The client most likely sends a fire request to the server, and the server calculates whether it hit somebody. However, because my position is messed up, the server probably gets confused, allowing me to kill players. Now, instead of guessing things about the server, let's open up the PySpades code and actually understand how the server handles everything. The main file is server.py. It basically handles all of the requests it receives from players and decides what is legal and what is not. It also decides when it needs to correct things, among many other tasks. This is the code that handles a position packet received from a random player. First, it checks the spacing between different position packets. Then it checks the actual values of the position. Then, it checks whether the position is valid, and even inside that function, it performs some kind of speed hack check. Finally, only if the freeze animation is false, whatever that means, it sets the player's position to the reported position. After reading more of the code and searching for some kind of logic that is not fully checked by the server, I stumbled upon the weapon input packet. This packet is responsible for telling the server that the player has fired their weapon. It can represent both the weapon and the spade. As we can see, the server performs 0 checks on the actual legitimacy of the packet. This means that we can forge as many weapon packets as we want, and they will all be accepted by the server and sent to all the other players. By tweaking random values in the client-side code responsible for weapon stats, we get this.
Okay, gamers, I think that's enough for this video. Let's summarize what we did. We learned what open source games are, how we can approach hacking those games, how wall hacks work, and a lot about game servers. During the filming of this video, I also created an aimbot, and I actually found a 0 day in the client's code that allows me to crash other players' games and potentially gain full control over other clients using a specifically crafted payload. But because this shit is hella illegal, I can't show it to y'all. Anyway, guys, if you enjoyed the video, please drop a like and subscribe. It would mean the world to me. Also, please let me know in the comments what kind of content you'd like to see next. Maybe you want me to continue with game hacking, go into much more technical detail, do the opposite, and focus more on gameplay, or even solve some really hard hacking CTFs. It's all up to you. See you in the next video, gamers.